Here we're asked to calculate the derivative of 1 over 2x minus 1 using the definition of the derivative. So we let f of x equal 1 over 2x minus 1, and recall that the definition of the derivative of f at x is the limit as h goes to 0 of f of x plus h minus f of x over h. And now we fill in the details and calculate this limit. So this is the limit as h goes to 0. F of x plus h is what I get by replacing the x by x plus h in the definition of f. I must subtract off f of x and divide by h. Now I have to subtract these two fractions. So I find the lowest common denominator by multiplying the denominators. I divide this lowest common denominator by the first denominator and multiply the answer by 1. So I get 2x minus 1 times 1 minus, I divide this common denominator by the denominator here to get 2x plus h minus 1 times 1 as the numerator there. And now I must divide everything by h, but anything divided by h is the same as multiplying by 1 over h. Now I can cancel some things. So expanding this a little, I get that that's the limit as h goes to 0 of 2x minus 1 minus 2x plus 2h minus 1. And we see here that the 2x will cancel, and also the minus 1 will cancel. So this is the limit as h goes to 0 of minus 2h over 2 times x plus h minus 1 times 2x minus 1 times 1 over h. Now the h's will cancel, and x is a constant. It's not changing as I calculate the limit. So as h goes to 0, this denominator goes to 2x minus 1 squared. And this is not equal to 0 unless 2x minus 1 is 0. And that's an exceptional case here, but for any other x, any x other than x equals 1/2, this limit exists, and it equals minus 2 over 2x minus 1 by 2x minus 1. And that's minus 2 over 2x minus 1 squared. And that is the derivative of f with respect to x, and we can see it exists everywhere except when x equals 1/2.